The KAAN National Combat Aircraft Program, managed by Turkish Aerospace Industries (TAI), represents a foundational shift in Turkey's defense and technological strategy. It is a multi-decade, multi-phase initiative with the ultimate objective of ending foreign dependency for critical military hardware and establishing Turkey as a center for advanced aerospace technology. The program's scope extends far beyond simply building an aircraft. It encompasses the creation of an entire industrial ecosystem capable of researching, developing, manufacturing, and sustaining a fifth-generation fighter jet and its subsequent iterations. This includes advancements in fields such as computational fluid dynamics, radar-absorbent material science, advanced metallurgy for engine components, complex systems integration, and artificial intelligence for avionics and mission systems. The aircraft itself is designed from the outset as a twin-engine, air dominance fighter with multi-role capabilities, meaning it is intended to secure control of airspace while also being able to engage ground and naval targets. Its physical design incorporates key tenets of stealth, or low observability. This is achieved through a specific shaping of the fuselage, wings, and tail surfaces to deflect radar waves away from their source. The airframe features aligned edges, chined edges on the nose, and body-conforming panels to reduce its radar cross-section. Further reducing its signature, all weapons are carried internally in dedicated bays, which open only briefly for weapon release. The canopy is treated with a special coating to minimize the radar return from the cockpit interior. The materials used in its construction include advanced composites and carbon fiber reinforced polymers, which are both lighter and more radar absorbent than traditional metals, contributing to both performance and stealth characteristics. The Avionics suite is planned to be among the most modern in the world. It is designed around the concept of sensor fusion, where data from the Active Electronically Scanned Array (AESA) radar, Infrared Search and Track (IRST) system, Electronic Warfare Suite, Radar Warning Receiver, and data links are combined by a powerful mission computer. This computer presents a single, unified, and simplified tactical picture to the pilot on large area displays within the glass cockpit, significantly reducing cognitive load and enhancing decision-making speed and accuracy. The system is also being developed with an open architecture, allowing for new software, hardware, and sensors to be integrated throughout the aircraft's service life without requiring a complete structural overhaul. Furthermore, the design philosophy includes the capability for manned-unmanned teaming, where a single KAAN aircraft could potentially command and control a flight of loyal wingman-type unmanned combat aerial vehicles (UCAVs), acting as a force multiplier in contested airspace. The development and testing methodology for KAAN is a systematic, block-based approach. This involves building several prototypes, each with a specific testing focus, leading incrementally to the final operational aircraft. The first of these, Prototype 0 P0, was used for the initial, critical phase of flight testing. Its successful maiden flight on February 21, 2024, from Mirdad Air Base, was a fundamental proof of concept, verifying the basic airworthiness, flight control laws, landing gear operation, and low-speed handling qualities of the airframe. A subsequent flight in May 2024 allowed for the expansion of this initial envelope, testing the aircraft's behavior at slightly higher speeds and different altitudes. The data gathered from these P0 flights is invaluable and is being directly fed into the assembly of the next prototypes. The second prototype, Prototype 1 P1, is currently in an advanced stage of assembly. This unit is more representative of the intended production design, incorporating subtle but important aerodynamic and structural refinements identified from the data analysis of P0's flights. The P1 aircraft is scheduled to begin its flight test campaign in 2026. It will be tasked with a more aggressive expansion of the flight envelope, including testing at high subsonic speeds, supersonic speeds, and at the extremes of its operational altitude. Later, P1 and subsequent prototypes will be used to test the integration and functionality of the mission systems, including the radar, electronic warfare suite, and the opening and closing sequences of the internal weapons bays. The plan is to deliver the first batch of 20 KAAN Block 10 aircraft to the Turkish Air Force by 2028, representing the initial operational capability. A parallel and equally critical track of the program is the propulsion system. The initial flight test aircraft and the first Block 10 production jets will be powered by two General Electric 110, GE, 129, turbofan engines. Turkey has formally applied for the required export licenses from the United States government for these engines. This choice provides a reliable, well-understood power plant for the development and initial service phase, de-risking the airframe development. However, the strategic core of the program's long-term autonomy is the indigenous TF-35,000 turbofan engine project, managed by TUSA's Engine Industries (TE). Developing a new, high-thrust combat aircraft engine is an immense engineering challenge, involving extreme temperatures, pressures, and material science. The schedule for the TF-35,000 is therefore deliberately longer. The conceptual design phase is reported to be in its final stages. The project roadmap aims to have the first prototype engines built for static bench testing by the end of 2025. Comprehensive ground testing, where the engine is run at various power settings to measure thrust, specific fuel consumption, and operational stability, is scheduled to commence in 2026. The ultimate objective is to integrate two fully certified TF-35,000 engines into a KAAN prototype and begin a dedicated flight test campaign around 2032. The success of the TF-35,000 is considered non-negotiable for Turkey to achieve unrestricted control over the production, future upgrades, and perhaps most importantly, the international export of the KAAN fighter. The program has also developed a significant international dimension, which serves both financial and strategic purposes. Indonesia has been formally confirmed as a program partner, having signed a comprehensive agreement for the procurement of 48 aircraft. This partnership likely involves financial investment and potentially some level of industrial workshare. Furthermore, there are ongoing and advanced discussions with several other nations. Saudi Arabia has been reported as expressing strong interest, potentially as a major financial partner and customer. Pakistan and Azerbaijan are also frequently cited as potential future customers or minor partners, given their existing defense relationships with Turkey. This international outreach is crucial for distributing the immense development costs and for establishing a user base that can support the long-term economic viability of the program, making it a sustainable enterprise rather than a one-off national project. In essence, the KAAN program is a monumental undertaking proceeding on multiple, interdependent tracks. It involves the meticulous and sequential flight testing of increasingly sophisticated prototypes to validate the airframe and core systems, running in parallel with the decade-long development of a domestic engine to ensure ultimate strategic freedom. Every step, from the first flight of P0 to the assembly of P1, from the application for F-110 licenses to the upcoming ground tests of the TF-35,000, is a calculated move within a meticulously planned schedule aimed at delivering a foundational asset for national defense and establishing a permanent, sovereign capability in the highest echelons of aerospace technology.